Okay, so let's look at question number 4, a question on a topic materials and energy under a subtopic density. The diagram shows an experiment on density. Question A, Roman numeral 1. What is the volume of the water used in the experiment? So the volume of the water, just look at where water is in the measuring cylinder. So water in this case is at 50 cubic centimeter. So the answer is 50 cubic centimeter. So ensure that as you are writing the answer, you include the units. So the answer is 50 cubic centimeter. That's the volume of the water used in this experiment. Question A, Roman numeral 2. Determine the volume of the stone. Determine the volume of the stone. Okay, so as you can see, the first cylinder is showing the initial volume of water. Okay, that is 50 cubic centimeter. Now after immersing in, after putting in the solid or the stone into the cylinder, the water level had to rise from 50 to 70. Okay, so there was an increment in terms of the volume. Okay, from 50, then it had to move from 50 to 70. Okay, so where the water was the initial volume of water, that is what we call V1. Okay, where the water was in the first place before we had to put in the stone. The water was at 50 cubic centimeter. That is our V1. Then after we put in that stone into the cylinder, the water had to rise from 50 to 70. So that 70, that is our V2. 70 cubic centimeter is our V2. So determining the volume of the stone, or finding the volume of the stone, you say volume is equal to V2, which is the final volume, minus V1, which is the initial volume. So V2 is 70 cubic centimeter minus V1 is 50 cubic centimeter. So 70 cubic centimeter minus 50 cubic centimeter, you obtain 20 cubic centimeter. So ensure that your answer should consist of, should have correct units. Ensure that you write correct units. Okay, so the answer is 20 cubic centimeter. Just say 70 cubic centimeter minus 50 cubic centimeter, which is giving us what? 20 cubic centimeter. Question B. Question B is saying, explain why the strain for lowering the stone in water must be very thin. Why are we supposed to use a very thin strain? Okay, so the reason is to avoid the strain displacing water, thereby making the volume of the stone incorrect. So if we use a strain which is not thin, we realize we're going to have the strain can cause displacement of water, which can affect the volume of the stone. Okay, so the reason why we use a very thin strain, it is to avoid the strain displacing water, thereby making the volume of the stone incorrect. Okay, then question C, calculate the density of the stone if it had a mass of 60 grams. Calculate the density of the stone if it had a mass of 60 grams. So they are saying show your working. That's an emphasis. So number 1, since we are told to calculate the volume, we need to write the formula for calculating volume. So for calculating density, so calculate the density of the stone if it had a mass of 60 grams. So density is equal to mass over volume. Density is equal to the mass divided by the volume. So we can now substitute Where there is mass, you put 60 grams, and where there is volume, you put 20 cubic centimeter. Now when you divide 60 divided by 20, you obtain 3 grams per cubic centimeters. So this is 2 marks. Okay, so how are the marks allocated? The substitution, you get 1, the formula, and substitution, you get 1, and then the correct answer with correct units, you get also 1 mark. That gives us 2 marks. So take note, guys. You write the correct formula, then you substitute nicely, and then for the answer, you also include the correct units. You get 2 marks. Okay.